For the first example in Chapter 2, we have a pickup that is driving for a while, and then the driver gets off and walks for a while. So we know that the final X position is the driven distance of 8.4 kilometers plus the walking distance of 2 kilometers. So we know that 10.4 kilometers is the distance from beginning to end. And now we can say that the displacement d vector is nothing more than delta x, which is x final minus x initial. And if we assume we start at 0, then we get 10.4 kilometers minus 0 kilometers, or 10.4 kilometers. So now, for part B, we know that the walking time is half an hour. So we can say that T sub W for time for walking is 0.5 of an hour, which is the same as 30 minutes. And we can say that the time it takes to drive is the distance that we drove over the velocity for driving. And that's the same as saying 8.4 kilometers over our velocity was 70 kilometers per hour. If we do this calculation, we get about 0.12 hours. So this means that the total time T sub tilt is going to be the driving time, the walking time, sorry, of 0.5 hours plus the driving time of 0.2 hours. This is the same as 0.62 hours. And lastly, for part C, whereas for the average velocity for the whole trip, the average velocity is the total change in displacement over total time, which is 10.4 kilometers over 0.62 hours, which is 16.8 kilometers per hour. And then if we use significant figures, we have to stick to 2 sig figs, which makes our answer 17 kilometers per hour.